Welcome to Otisam Mathematics. I am on the series Relation and Function. So far I've considered functional notation, domain of a function, range of a function. So if you are joining me for the first time, I will urge you to go back and watch those videos for better understanding of today's lesson. In today's video, I'm looking at types of function, to be specific, one-to-one function. There are so many types of function, but I'm going to deal with one of them, which is one-to-one function. A function is said to be one-to-one if for every element x, a member of x. Now in our studies, we'll be looking at x always represent the first set. I mean, if you have two sets, x and y. Now, if a function connects one element in the first set to a specific element in the second set, then we have one-to-one. So, if there exists a distinct and unique y, small y, a member of big Y, such that f of x is equal to y, which is also a real number. So this is the second set y. So we are saying that if a function f takes a unique element in the first set to another unique element in the second set, then that function is one-to-one. So you can get a better view looking at this diagram. We have two sets, set x and then set y. If a function here, f, is taking elements in the first set to elements in the second set. Now look at the mapping. A maps to 1, B maps to 2, C maps to 3. So each element here has one and only one image in the second element. Then we call that function one-to-one. Mathematically, how do we define a one-to-one function? So a function f such that x maps to y is said to be one-to-one if for all elements, when you pick two elements in the first set and then you find the functional value of the first element, that's if f of a is equal to f of b, and then when you simplify the function and then a is equal to b, then we say that that function is one-to-one. Now we are going to take some example and that will give you better understanding. So example, a function f such that x maps to x squared plus 1 is defined on the domain, the set 1, 2, 3. We are to use arrow diagram to show whether or not the function is one-to-one. Okay, so we have this function, this is the rule, and this is the domain. So what we are going to do is to find the functional value of the domain. So let's look at. So f of x is equal to x squared plus 1. So to find the functional value of 1, you put 1 in the function. Wherever you see x, you put 1. So 1 squared plus 1, we are having 2. And then f of 2, when we simplify, we are getting 5. F of 3, 2, we are getting 10. So we were told to use arrow diagram. Now look at the domain. Each of the domain has one and only one member in the second set. So this makes the function one-to-one. Another example, show that the function f of s is such that x maps to 5x plus 2 is one-to-one. So to show, you choose two elements. So for f to be one-to-one function, f of a must be equal to f of b, which implies that when you simplify, a is equal to b. That is, when you choose A, B, member of the first set. So we find the functional value at A. We find the functional value at B. We equate them and simplify. If at the end of the day we have A to be equal to B, then the function is 1 to 1. So let's find f of A. So f of A will be equal to, wherever you see x, we put A. So 5A plus 2. Let's find f of B. F of B will be 5B plus 2. So we are saying that f of A must be equal to f of B. And if that is the case, this implies that f of A is 5A plus 2 is equal to 5B plus 2. So 2 here, 2 here, I'll go to this side. So we are having 2 minus 2. So 5A is equal to 5B plus 2 minus 2. And this will go to 0. So we are having 5A is equal to 5B. So let's divide both sides by 5. So over 5 here, over 5 there. So this will cancel. So we are getting A to be equal to B. Since A is equal to B, we conclude that F is 1 to 1. Yes. Let's look at the second part. Now, before I show you the solution, I want you to pause the video and then work it out yourself. Determine whether or not the function g of x is equal to 6 on x squared plus 15 is 1 to 1. So, as usual, you pick two elements. This time, let's pick maybe P and then Q, a member of the first set. Then the function is g of x. So if this is supposed to be 1 to 1, then g of P must be equal to g of Q. And this implies that P must be equal to Q. So it's not always that you choose A, B. You can choose any two different letters. Good. So let's find g of P. So g of P is equal to 6 on P squared plus 15. And then g of Q is equal to 6 on Q squared plus 15. So g of P is equal to g of Q. So this implies that 6 on P squared plus 15 is equal to 6 on Q squared plus 15. So let's cross multiply. So when you cross multiply, we are having 6 times P squared plus 15 is equal to 6 times Q squared plus 15. Now 6 is here, 6 is here. When you divide both sides by 6, 6 will go. So we have P squared plus 15 is equal to Q squared plus 15. So P squared is equal to Q squared plus 15 minus 15. So P squared is equal to Q squared. So if you want to find P from quadratic equation will be plus or minus square root of Q squared. So P is equal to plus or minus Q. So this means that P is equal to Q or minus Q. So let me draw the diagram. So assuming that this is the domain P, and then you have the codomain Q, then minus Q. So P is mapping to Q, and at the same time P is mapping to minus Q. And according to definition of 1 to 1 function, each member here must have one and only one image. So P is having two images. We conclude that G is not one-to-one function. So since P is equal to minus Q or Q, G is not one-to-one function. Yes, you can also find Q. So when you find Q, Q will be equal to two values of P, and which will also make it not a one-to-one function. Let's look at the last one. I want you to try this one. You try this first before I show you the solution. So once again, show that the function is such that x maps to x squared minus 36 over x squared. Now look at this condition. Very important. X must be greater than 0. So once again, you choose two elements. Member of x such that h of A is equal to h of B, which implies that A is equal to B. So let's find h of A. So h of A will be equal to A squared minus 36 over A squared. Now the condition is A must be greater than 0. Very important. And then h of B is equal to B squared minus 36 over B squared. Once again, bring your condition. B must be greater than 0. So h of A is equal to h of B. So this implies that A squared minus 36 over A squared is equal to B squared minus 36 over B squared. So we can cross multiply. When you cross multiply, we have A squared times B squared minus 36, which is equal to B squared times A squared minus 36. So let's expand. We have A squared B squared minus 36 A squared is equal to B squared A squared minus 36 B squared. So we have A squared, this is A squared B squared, and B squared A squared is the same as A squared. You can bring it here. A squared B squared minus 36 A squared is equal to minus 36 B squared. So A squared B squared minus A squared B squared will go to 0. So we have minus 36 A squared is equal to minus 36 B squared. So minus will cancel. 36 will cancel. So let's divide both sides by minus 36. So this will cancel. So you have A squared is equal to B squared. So to find A will be take the square root on both sides, plus or minus square root of B squared. So you have A is equal to plus or minus B. But the condition is, since A is greater than 0, A cannot be equal to negative B. A is equal to B. So A cannot take negative value of B. Therefore, H is a one-to-one function. Thank you very much, viewers, for watching this video. I know you have enjoyed the video. If you still have not subscribed, kindly click on the subscribe button. You can also set your notification on so that anytime I drop a video, you can easily get it. You can like the video. If you don't understand anything, you can give your comment, write it down, and I will respond to it.